Speaking of adding and subtracting polynomials, the main thing here is we want to have a good vocabulary. If you look at the top, it talks about a polynomial is a monomial or a sum of monomials that forms an algebraic expression. We call monomials each of the monomials in a polynomial term. Here, a term can be a number, a variable, or the product of numbers or variables. Example of polynomial in its terms would be 2x squared plus 3x minus 5. Our terms are each individual set of numbers there. So for a monomial, it's a single term because it's got mono. That's the first thing, is that it looks like mono means one. Binomial, bi indicates two, so it has two terms. If we have a polynomial that has three terms, we have a trinomial, which is triples. Those are the words that we need to look at when we're determining polynomials, is the vocabulary that we're trying to find. If it's more than three terms, we simply say it's a polynomial. Notice that they are, a polynomial is the sum of monomials, and so if we're looking at these down here that have an addition or subtraction, that indicates our term. Let's look at examples here. It says identify the type of polynomial and list the terms. Since this has two terms, then we have a binomial. In our terms, we have 2x and 3. Here we have three terms, so 3 is tri. We have a trinomial. In our three terms, we have 3y to the third, 4y, and negative 12. The number that's in front of it adds to it, just like the negative 5 is different. Number 3 has one term. There's no addition or subtraction here. We have a monomial. Number 4, we have four terms. Since we have four terms, 3t to the fourth, we have 5t to the fifth, negative 4t to 2. This will be a polynomial. And we've got multiple terms. Okay, we've done this part before. Like terms. Remember when we talked about like terms before? They have the same variable with the same exponents. For example, 2x and 3x are like terms. 5x squared, 9x squared are like terms. They have the same variable with the same exponents. So we're going to look at which ones are like terms here. They have to have the same exact letters. Doesn't matter about the number in front. That's a coefficient. We can only combine them if these are the same. Those are like terms. These are not like terms. It's x and x squared. These are like terms. And this is a constant. Does not have any letters. And so those are like terms. Okay, we're going to add polynomials. We're going to collect the like terms using the properties. Like I said, we've done this before. We usually didn't call it addition and subtraction of polynomials. So we're going to set them up a little bit differently. Even though this is like here, notice that we have like terms, 2x and negative 4x. There's nothing in front of these parentheses except the 1. So we can think about this as simply 2x plus 3 plus a negative 4x plus 5. So if we combine our like terms here, we have 2x and negative 4x. We have 3 and 5. So this is nothing new from what we've done before. 2x and 4x is negative 2x. 3 and 5 gives us 8. And so those are our combining like terms on our polynomial. So number 10, combine like terms. We have these two. 2x squared. The number that's in front, it has to go with the number. That's a negative 8 and a positive 6. We have a negative 2x and then 7 and a negative 12 gives us a negative 5. A little bit better. And so those are our sum when we're combining like terms. And then on 11, 5x and 6x is 11x squared. If nothing combines with that 2x, we simply keep it the way it is with the sign that's in front of it. We get 2x plus 1. That's combining like terms. And on 12, we want to start these with the highest exponent. So we look through and say, okay, there's an x squared. There's nothing to put with it, so I'm just going to write x squared. Then we can look at our x's. We have positive 8 and negative 9. We have negative 1x. And we have negative 7 plus 4 is negative 3. So those are like terms that we can find. And we can't find out what it is. It's not equal to anything. It's not an equation. It's an expression. Also, notice on the exponents here, it says that the exponent does not change. When we add these together, it still stays x. We've been talking about exponent rules, and if you multiply, you add your exponents. We're not multiplying. We're simply combining like terms. Okay, so when the polynomials become more complex, then sometimes it's easier if we add them in columns. What they mean by that is that we can line these up where the same like terms are together. The problem is that sometimes we're missing a term. So in this case, if you're missing one, we need to rewrite it where we have leaving a space for that term. You can say maybe 0x to the 4th minus 2x to the 3rd plus 6x squared. We don't have a 0x, so 6 plus 0x plus 3. Our second polynomial is going to be underneath that. 5x to the 4th. Minus 7x squared plus 6. You can see we've got gaps in this one too. We don't have a third term. We don't have a single x. So we only combine our like terms and add these straight up and down. 9x to the 5th doesn't combine with anything. 5 and 0, which is 5. Negative 2 and 0, negative 2. So we get negative 13. I'm just sure it fits. That should be a constant. So units are negative 2x to the 3rd minus 1x squared plus 0x plus 9. And that's correct. And this is as far as we can go. It's kind of long. We can't combine anything else. So if you prefer to combine like terms together, which is fine. We go through and get 4x to the 3rd and combine with this one. Have 2x to the 3rd. Always with the sign that's in front of it. X squared doesn't have anything to combine with. Negative 9x. Negative 8x is negative 17x. Squared. And then 2, 3, 9, and 7, we can combine together. So 10 minus 9 equals 1. Okay, these ones we need to be especially careful about. We've seen these before. I leave them here. To subtract polynomials, you'll find it easier to add the opposites of the polynomial that's being subtracted. This right here, that's subtraction. That's the same as having a negative 1 right here in the front. You have to multiply that through. We said before, if you multiply a negative through the parentheses, it's going to change your signs. So let's rewrite it. 9x squared minus 3x plus 7. This one, we'll have it, rewrite that. This was positive, it's going to be negative. Positive, it's going to be negative. This was positive, it's negative. Now we're trying to correct it and combine like terms. 7x squared minus 7x plus 1. And hang on 16. Change sign. Let's rewrite it. 7x to the fifth plus x to the third minus 9x. This is going to change all of these signs. Minus 3x to the fifth plus 4x to the third minus 5. Combine our like terms. We have 7x to the fifth and 3x to the fifth equals 4. So we have 1x to the third and 4x to the third. We add those together. 9x has nothing to combine with it, and 5 has nothing to combine with that one. So 4x to the fifth plus 5x to the third minus 9x equals 5. And that's what we're going to have when we're subtracting polynomials. Same to do with work, combining like terms. Pay special attention to our sign.